So welcome everybody. I'm Mike Shanahan. I am the Planetarium Director at the Jennifer Chalsty Planetarium at Liberty Science Center in Jersey City, New Jersey. Now we see a lot of folks from around the country and even outside of North America joining us. We are very close to Manhattan, right across the Hudson River. So when we do reopen, we'd love to see all of you who are joining us come and join us in our planetarium at Liberty Science Center. Our planetarium, the Jennifer Chalsty, is the biggest planetarium in all of the Americas, 90 feet in diameter. And we use our Digistar software by Evans and Sutherland to bring the night sky and astronomy to life in our giant dome. So we are able, thanks to the generosity of Evans and Sutherland, to use the same software we use in our dome to present online programming during the time that LSC is closed. And we'll be using Digistar and other elements to present our show today. So joining us today, we have Andrew, who is our other presenter on these programs currently. He is in the chat box and is responding to questions about astronomy. So put your questions in there. And we'll also leave some time at the end of the show for any questions that you may have. Like all of us, we are a nonprofit organization, like many museums and planetariums. If you feel like supporting our efforts here in terms of both STEM education and taking astronomy and space sciences to the world, if you go to lsc.org/donate, that's a great place to donate to support us. So thank you for, again, joining us. And we're going to talk about getting back to the moon with the Artemis program. And that is a program designed to get us back to the moon by the end of this decade with a human mission, including putting the first woman on the moon. So to talk a bit about that, we're going to begin first of all by going to, of course, where all of astronomy has its origins. Let's go out to the nighttime sky, or almost the nighttime sky. Here's the sky you'd actually see tonight about an hour before sunset. Now here in the Northern Hemisphere, we are getting very close to the longest day of the year. That's the 20th of June. And so it gets dark pretty late here. Let's go out to the evening sky and check out where the moon is going to be tonight. Now, whether you're here in New Jersey or even in South America, the moon's going to be out tonight and look the same all over the world. We do share the moon in common. But if you're trying to find the moon tonight, it's going to be really kind of hard to see it as you're looking towards the western sky, because when you have a full moon, it rises in the east as the sun goes down in the west. And we don't exactly have a full moon tonight, but we're 1 day away from the moon being full. I'm not sure what your weather is going to be like in your neighborhood, but we are predicting some mixed cloud coverage tonight. But here's hoping you can see the moon in between the clouds tonight. So here it is, 10 o'clock. The moon will be here just 1 day shy of being a full moon. And the moon will be in the constellation of the Scorpion tonight. There is the Claw, the Heart, Antares, and the Stinger going down below the horizon. So here's the moon as you'd see it this very evening. Now, if you live in Africa or Asia or Europe, then tomorrow when the moon is full, you may have heard you're going to have an eclipse of the moon. And so I wanted to talk a bit about that. There are different kinds of lunar eclipses, and the one tomorrow is called a penumbral lunar eclipse. And that's a kind that is barely visible. Let's go into that a bit more to talk about why lunar eclipses happen in the first place. So we have the Earth going around the sun, of course. So here we have the sun, there's the Earth, and there is the moon going around the Earth. You only have a full moon when the sun, the Earth, and the moon are in a straight line with the Earth in between. And every so often, the moon wanders into the Earth's shadow, and that causes a lunar eclipse. But not all Earth shadows are made the same. So this dark inner shadow is called the umbra, Latin for shadow. And if the moon goes entirely into the umbra, you get a wonderful, spectacular total eclipse of the moon, occasionally called a blood moon, as the moon turns dark, can sometimes appear to disappear, or turns an eerie copper color. Those are spectacular. That's the good news. Here's the bad news. There is no total eclipse of the moon visible anywhere on Earth in the year 2020. You have to wait till May 26th of 2021 and then be in the Pacific to see the next total lunar eclipse. Shout out to my former colleagues in Honolulu, Hawaii. They'll have a great view of that next total eclipse of the moon. Now, sometimes the moon doesn't go entirely into that dark inner shadow. It only goes partway in. And when you have that situation, you have a partial lunar eclipse. And those are also really, really cool because you can see part of the moon still lit like a bright, normal full moon, while the other part is in darkness as it's entering the umbra. And we'll see a partial lunar eclipse over New Jersey in about a year and a half on November 19, 2021. So the third flavor of lunar eclipse is what we have tomorrow in Europe, Africa, and Asia. The pale outer shadow of the Earth is called the penumbra, and there are eclipses like happen tomorrow where the moon is only in that faint outer shadow. And during penumbral eclipses, there's barely any difference between a normal full moon and a penumbral eclipse. So if you're in Europe or Asia or Africa tomorrow night, look at the moon, see if you can tell any difference whatsoever. Now in the Americas, we won't quote unquote see this penumbral eclipse tomorrow, but the next full moon on July 4 will be a penumbral lunar eclipse over all of the Americas. So that night, Independence Day, late in the evening, look up at the moon and see if you can tell any difference whatsoever. We tend to downplay penumbral eclipses in our business just because there's so many amazing things to see in the sky that we didn't want to overpromote what is a very faint view. All right, so I just wanted to mention that because you may be hearing about that coming up. So penumbral eclipse in Europe and Africa and Asia tomorrow. So there is the moon, and we have gone to the moon with a number of missions in the 60s and early 70s, and it all began with this. This is Sputnik, the first artificial satellite ever launched, October 4, 1957. The Soviet Union launched the first artificial satellite, the size of a beach ball, but it caused us to freak out in the United States because it seemed like the Soviets were way ahead of us in terms of space technology. It sort of got the space race going. I probably wouldn't be here today if it wasn't for Sputnik. My last two museums I worked in, the Pacific Science Center in Seattle and the Planetarium at Bishop Museum in Hawaii, were both built in partial response to getting up on getting what we now call STEM, science education, really going strong here in the US. So Sputnik did begin the rush to the moon, and President Kennedy, in a very famous speech in 1962, laid out the goal of us going to the moon before the end of the 1960s. That it would be hard, he was saying, but also it would be a very, very noble and cool thing to do. Here's a little bit of his speech.
On an untried mission to an unknown celestial body, and then return it safely to Earth, re-entering the atmosphere at speeds of over 25,000 miles per hour, causing heat about half that on the temperature of the sun, almost as hot as it is here today, and do all this, and do all this, and do it right, and do it first, before this decade is out, then we must be bold.
I was also raised in Massachusetts, so you may notice I have a little bit of an accent like Kennedy. There, the similarities end. So he inspired the U.S. to really get going on getting back to the moon by the end of the 1960s. And the mission to do that was called the Apollo program. So let's talk a bit more about both the Apollo program and the moon itself. So just some basics. The moon is our only natural satellite. Mercury has no moon, Venus has no moon, and we have one moon. It is, on average, just under 250,000 miles away, which may seem far, but compared to anything else in the solar system, it's really quite accessible. You can get there in about 3 days in a spaceship. The moon is quite a bit smaller than the Earth. It's about 2,100 miles in diameter, so 2/3 of the width of the continental US, and has a low gravity, so low that it can't hold an atmosphere. So with no air on the moon, there is no chance that the craters formed long ago would be worn away. So these ancient craters remain visible, no erosion, no rain wash, and again, no atmosphere. So the first Apollo mission to go to the moon was actually Apollo 8, which orbited the moon at the end of 1968, December 1968. Like this year, a very challenging year. But at the end of that difficult year, 3 astronauts orbited the moon and showed us, for the first time in history, the little blue marble of the Earth seen from that great of a distance. That laid the groundwork for the landing on the moon in July of 1969 of Apollo 11. 7 months later, Neil Armstrong and Buzz Aldrin, who by the way is from New Jersey, became the first humans to walk upon the moon. Now, Apollo 11 was actually the first of 6 successful landings on the moon. 12 astronauts walked on the moon, and the later missions, Apollo 15, 16, and 17, even brought a moon buggy so they could kind of travel far afield to collect rock samples and bring them back to their lift vehicle. So December of 1972, the last human left the moon. The last footprint, that of Gene Cernan, who was on that mission, that would never have thought probably at that point, December 1972, that almost 50 years later, we would never have gone back with a human mission to the moon. But we had other priorities. Getting the space shuttle going was a major priority, and also getting the space station built. But now going back to the moon seems like a good idea, in part because we've now found evidence of ice, i.e. water, on the moon. That's a very important factor in terms of going deeper into space. And it's a good place to really test out the skills and technologies we need to go further afield to an asteroid or to go to Mars. But if we are going to return to the moon in this decade, many, many things have to happen before we're ready to have a human mission back on the lunar surface. So first of all, we have to get a launch vehicle. We don't have a launch vehicle large enough right now to get our astronauts to the moon, but it is being built right now. It's called the Space Launch System, or SLS, and it's going to be the biggest rocket since the Saturn V moon rocket. Right now, this is being tested at the Stennis Space Center, a NASA center in Mississippi, and it uses some of the technology from the days of the space shuttle. The main tank is modeled or designed after the external tank of the space shuttle. And like the space shuttle, it has solid rocket boosters to give it an extra lift. And the RS-25 rockets, the 4 of them at the base, are space shuttle rockets. And this beast is going to be powerful enough to get the Artemis mission on its road to the moon. Again, right now it's not complete. They are doing tests right now. The tests were somewhat delayed by the COVID crisis. Stennis Space Center was closed for 2 months, but is now open again and going back to testing the main tank of the SLS, the Space Launch System. So they hope to launch this with initial tests within a couple of years. And it is a vehicle that will provide the kind of heavy lift needed to get the astronauts heading out towards the moon. Now, one more important difference between this and Apollo, I'll try to point out similarities and differences, is that the landing vehicle will not be on board the SLS like it was on the Saturn V rocket during the Apollo time. It'll be launched separately, either on another SLS or in another heavy lift vehicle, and then will dock at the moon with the astronauts. Now, of the elements of the Artemis program, the one that's most good to go right now is the actual Orion capsule that the astronauts will be traveling in. So as soon as our solid rocket boosters fall away, we'll go ahead and we will have a look at that capsule. Named for the constellation Orion, The Orion capsule is in some ways an Apollo capsule on steroids. It can handle more, it can handle up to 6 astronauts. And then behind it, the service module being designed by the European Space Agency as one of their main contributions to Artemis. This is the part that will go heading off to the moon. We're still, of course, here in Earth orbit right now. And that's an important point right away. One way that Artemis is so different from Apollo is that it's an international effort, and it's the European Space Agency that is designing actually the service module that will provide oxygen and support and provide the oomph to head off to the moon for that 3-day voyage to the moon. So we have a capsule, the Orion capsule, that's in really good shape. We have a heavy lift vehicle, the SOS, that's getting closer to being good to go. Now let's follow in the footsteps and see where we're going to land, because that's also very different from the Apollo mission landing sites. So all of the Apollo missions went to an area near the equator on the side of the moon facing us. The moon has one side locked towards us all the time. But Artemis is going to head for the south polar region of the moon, a place we've never explored. Why? Well, in part, it gets back to the water issue. Having found ice in these deep craters that never see sunlight near the south pole of the moon, water is like oil was in the days of old-timey exploration days. Water gives you so much. You can drink it, but you can also separate it. H2O can be separated into hydrogen and to oxygen, and those are the 2 best rocket fuels that we have. And also, of course, we can breathe the oxygen. So landing, as is the plan, on the south polar region of the moon, a couple of things to note. As with the Earth, if you're near the poles, the sun never gets very high in the sky from a polar region. Here we have also Venus right next to it. Another thing to note, the constellation of Orion, for which the capsule is named, is there in the sky, and it looks identical to how you see it here on Earth. Now, you may not feel that way if, like me, you're from the North Hemisphere. Let me show you where Orion, the constellation, is. There is the star Betelgeuse, one shoulder star, the other shoulder star, Bellatrix. There's the belt. And here are the kneecap stars, Rigel and Saiph. So it looks upside down, but if you go to Australia, any place far down in the south hemisphere here on Earth, Orion is also upside down. But the stars themselves look identical on the moon and on the Earth. The stars don't change in the mere 250,000 miles from the Earth to the moon, and you can even use them to navigate by. So here you have the view of Orion as you'd see it from the south polar region, either of Earth or of the moon. So getting down there to the surface and beginning to do work there in the polar regions is an important part of the overall vision of Artemis. So we have the heavy lift vehicle being tested right now. We have the capsule in good shape. The first Artemis mission to send the humans to the moon will be an orbital mission, very much like Apollo 8 was, probably happening in 23 or maybe 24. But these astronauts will be able to, again, view the beautiful sight of the Earth from lunar orbit, as did the Apollo astronauts back in the days of the Apollo 8 flight. Of course, now they'll have high-definition cameras. So the first Artemis test will be an uncrewed, that's C-R-E-W-E-D, an unstaffed mission that will orbit the moon, maybe 22 or 23. The second one will be an orbital mission that will send astronauts around the moon and then back. And then currently Artemis 3, somewhere around 24 or 2025, will be the one to land on the moon. Again, these can slide. There are so many things that have to happen for Artemis to meet its mid-decade deadline. And also the part of the mission that is both the least well-defined and perhaps the most exciting is how you're going to get from the Orion capsule orbiting high up above the moon down to the lunar surface. And that's where a lot of the most amazing stuff is happening. And it's also an area in which things really differ between Apollo and the Artemis program. NASA, just about a month ago, awarded contracts to 3 commercial space operations to design the landing vehicle to get from Orion capsule down to the lunar surface. So that's a big difference in space exploration nowadays. Not only is it international, as in the European Space Agency building the service module for Orion, also commercial space companies have a big role now in NASA's projects. And just as SpaceX handled the launch of those 2 astronauts to the space station just last Saturday, several different corporations have proposals in to design the lander. And NASA just in April announced the 3 finalists and gave them some funding to further develop their 3 ideas. And so let's look at that, because that's a really good element that both conveys the fact that commercial aviation is really important now to what NASA does. And also, these are very radically different ideas of how to get a human being down on the moon. So here are the 3 finalists. Dynetics, which is based in Alabama. That's a corporation organization of about 25 different companies designing a lunar lander. SpaceX, that is Elon Musk's organization, he of also, of course, Tesla. And the national team, which includes Blue Origin, that's Jeff Bezos of Amazon's space company, but with some heavy hitters as well in the space biz, including Lockheed Martin and Northrop Grumman. They have come up with 3 radically different ideas of how to get from the Apollo capsule down to the lunar surface. In all 3 cases, by the way, these will have to be launched separately from Earth and sent out to lunar orbit. Well, only then will they dock with the Orion capsule. They'll be launched either on an SLS or on another heavy lift vehicle like the Falcon Heavy that SpaceX is developing. So let's see how these 3 possible landings are going to work. The one that is most similar to the plan for to what happened with Apollo is the national team led by Blue Origin. So that one calls for a design that looks a lot like the Apollo landing system, except it also has essentially a space tug attached to it that is going to get this landing device the long distance from where Orion is down to close to the surface. But then once that space tug pulls away, the rest of it looks kind of like the Apollo lander on steroids. The landing vehicle being designed by Blue Origin, and then Lockheed Martin designing the upper part. The upper part will then take off from the lower part and return to dock with the Orion spacecraft afterwards. So this is the one that NASA has given the most funding to so far. And NASA is saying that's not an indication that they have a leg up on that, but it just seems like that is one that has a lot of similarity to the Apollo mission, maybe the most realizable, maybe the one they go with first, while still maybe looking at these other options as well. So that was option 1, Blue Origin and the national team. The second one is called Alpaca, like in the animal. And this is being designed by the Dynetics team. And it is going to dock with Orion. And then it is a single unit that is going to do all the job of landing on the moon and coming back up off the moon. As it's coming in towards the southern polar region, you can see the long dark shadows where that valuable ice is hidden. It'll eject a couple of its fuel tanks and then land as a single unit. It's sometimes called the belly bouncer because it lands so close to the lunar surface. It'll at least be a really easy descent for the astronauts to get down to the lunar surface. Now, as I mentioned in passing, the sun is always very low in the sky when you're near a polar region of Earth or of the moon. So one design for the Alpaca is to have these vertical solar panels to catch as much of the sun's light as possible. Once the exploration is done, the entire unit then will lift off, return to dock with Orion, and head back to Earth in the Orion capsule. So those are two of the three options. I wanted to mention that NASA could well say, we want to keep all three options, or we're going to choose two, or going to choose one. February of next year, 2021, is when they'll make the next steps in this process. So for these 10 months, the three companies are working out their ideas and testing them, and then NASA will take another step to greenlight one or two or three of them. So one design, the third design of the three that may be saved and built on for another time, is a game changer by SpaceX, which is called the Starship. So they didn't do an animation for that, SpaceX did not, but the Starship, that is a general term for a range of spacecraft that SpaceX is developing. You may have heard that they are actually testing things out and have had a couple of test failures of their mock-ups in their launch site in Texas. And the idea is to have different kinds of these vehicles for different missions. So a Starship for landing on the moon, as in this case, won't need fins, for example, because you're not ever going to be in an atmosphere. So you don't have to be streamlined, just as the lunar lander in Apollo didn't need to be streamlined. It wasn't going to ever be in air. As this is coming down, the thrusters are way up here to slow the descent. That, having them way up here, avoids kicking up a lot of the dust as they're about to land. And this is going to be a vertical landing, much as you may have seen the boosters for various SpaceX craft land after they have completed their space missions. The other big difference here is just how big this Starship SpaceX lander is. You can get a sense of the size by looking at the astronauts right here. This thing is 160 feet tall and can get about 100 tons to the moon. That's about 4 times what we can get to the moon with the SLS, for example. You actually need an elevator to get from here down to the surface for the astronauts. This is also going to be kind of a docking area where it's going to go and dock with and undock from the Orion. So it's a really radical idea, but it could be a game changer, in part also because this vehicle is designed not only in a version for lunar landing, but they're working on versions as well for going to the space station and eventually into deep space. So it's going to be really interesting to see what happens as NASA in February of next year makes a decision of which of these landing craft to focus on more. But whatever is going to happen, it's going to be a really interesting, intriguing option for how to get human beings down to the lunar surface. So those are the three main elements. You need a heavy lift vehicle, the Space Launch System, SLS, which is being tested right now in Mississippi. You need a capsule to travel from the Earth to the moon. That's the Orion capsule, which is pretty much done. And you need a landing system to get from Orion down to the moon. And that is the one that is still very much of a work in progress, but has some really interesting possibilities. Now, the last thing is there is a fourth element of this as well that was going to be part of the early Artemis missions. Right now, it doesn't look like this fourth element will be used for the early Artemis missions, including Artemis 3, which is the one that will actually land with humans on the moon. But the idea is still one that NASA is pursuing, and that's to have a space station, but one that is orbiting the moon rather than the Earth. It's called the Gateway, and will provide a way to have a station right at the moon that various lunar missions could dock with and undock with. And with this idea for a space station actually at the moon, they could then have the Orion capsule come and dock here and then transfer through the Gateway to whatever landing module has been selected. This would also address one of the big concerns about Apollo, was we made this huge effort to get to the moon, but there was no reason to keep on going back. With a space station actually at the moon, that may be a way to really keep presence going and to really explore more possibilities in terms of getting to the moon and then eventually down to the moon as well. So it's going to be a really interesting time. There are so many variations and variables still in this project, but it is a really intriguing idea. And the role of commercial space companies and the international angle combined with NASA should make it a really interesting next few years in terms of the future of us finally getting back to the moon. So that is our program, and we'll now go ahead and see if there's any questions that folks have before we end our show. Thank you again for joining us. That's the end of our formal show. And again, if you want to support us, lsc.org/donate, always a great way to support us. Thank you all, and I'll be looking now at the questions here. Someone is wondering, is there a space station at the moon right now? No, we don't have a space station there yet. And we really do hope to get one there within the next decade or so called Gateway. But it'll be a while there before that we have that ability to do that. Emily is wondering if we will ever going to go to Saturn. So great question. So here's another advantage, Emily, of going to the moon. You can get there in 3 or 4 days. So going even to Mars with a human mission, which is one of our nearer planets, would take 6 to 8 months each direction. And our robots that have gone to Saturn can take as long as 10 years. So it's not undoable, but the amount of time it takes to go to a more distant planet like Jupiter or Saturn, it would be, just the length of the voyage would be a real challenge. You may remember the film 2001: A Space Odyssey, where most of the astronauts were put in hibernation because that voyage was going to take so long. And Saturn is twice as far, actually, away as the planet Jupiter is. A little bit of trivia, by the way, in the novel version of 2001: A Space Odyssey, they actually go to Saturn. With the technology of that time, trying to do a special effect of the rings of Saturn in a movie was so challenging, they, in the movie, decided that they would make Jupiter the destination instead. Mindy is wondering, how far is the International Space Station from the moon in comparison to its distance from Earth? So the ISS is only, it's less than 300 miles above us. So it's really, really close. So it's just barely above our planet. So 300 miles or less to the ISS compared to 250,000 miles away. So when they use the term low Earth orbit, that is correct. It's a really low orbit compared to the distance off to the moon. Someone is asking, how did Mars get its moon? So, okay, we didn't mention Mars. Mars has got 2 moons. So it's 0 for Mercury for moons, 0 for Venus, 1 for Earth, and Mars has 2 little tiny moons the size of Manhattan, and they are both captured asteroids. So they're called Phobos and Deimos. So we have a question about when will Orion be launched into space? We'll probably be doing a test launch. We're hoping as early as late 2021 or possibly 2022. Looking over the questions here. Jalpa is wondering, how is there no atmosphere? The bigger you are, the better your odds are of holding an atmosphere. So a small celestial body like the moon, little gravity, it's a pretty hard time holding on to its atmosphere. Mars also, quite small, has a very, very thin atmosphere, whereas the atmosphere of Earth and especially of Venus are very, very dense. Someone is wondering, how did the moon form? So there are many debates over that, but we're pretty sure now, in the early stages of the Earth's formation, we got smacked by a giant piece of space debris that almost destroyed the Earth, but instead broke apart parts of the Earth that then developed into becoming the moon. So the fact that the moon and the Earth are made of very similar stuff seems to indicate that it was a giant smack of the Earth long ago that led to the creation of it. Kirti is wondering, will humans go to Mars? That is a great question. So that is one of the reasons why we're going to the moon again, is to get more experience under our belt. Because going to a planet is so much more complicated than going to the moon. The Apollo missions took only 2 weeks. The Orion capsule is designed to be designed for a 3-week voyage. But in terms of the dynamics of getting to Mars and back, you're talking many months to Mars, and then once your human mission is on Mars, you got to wait for over a year for things to line up right again for the ride back. And then the ride back is going to take 6 to 8 months. So you're talking 2 to 3 years for a Mars mission versus 2 to 3 weeks for a lunar mission. So it is the only possible planet we can get to in this century. The planet Venus is nearer much of the time than Mars, but it is a horrendous place with incredibly thick atmosphere and heat. So Mars is definitely the planet to go to when we go to a planet. But the challenge is that we're talking 2 to 3 years for a Mars mission compared to 3 weeks for a mission to the moon and back. And so yeah, Deepa, going to Neptune is going to be even harder. So Neptune is 3 times as far from the sun as the planet Saturn is. And at 3 billion miles away, our spacecraft going to Neptune, the only one that ever went there, which is Voyager 2, took 12 years to get to Neptune. So imagine 12 years out, you're there for a year, and 12 years back. Your whole life could be put into getting to Neptune and back. Okay, seeing if there's any more questions here. We have a question about whether there is anything living on Mars. So we used to fear that Mars had life. Many science fiction novels talked about Martians coming to take our water. That was the plot of War of the Worlds. As far as we know, there's no life on Mars whatsoever. Water doesn't really exist in a liquid form on the surface anymore. Mars had more water back in the past, so maybe some forms of life could have got going on Mars long ago, but they weren't able to really survive if there was life once the planet dried out. So no life on Mars that we know of. We do hope that someday there'll be life on Mars, because eventually we do hope to get human missions to the red planet. Jessica is wondering, what is the distance of the moon from Earth? It's around 240,000 miles. We tend to say like 250,000 miles away, but it's a little closer than that. And it also varies quite a bit. So when it's at the closest point in its origin, of its orbit, which is called perigee, it's only about 221,000 miles away. If you have a full moon at that point, when it's at perigee, we use the term supermoon. We had one of those last month, actually, a supermoon that was occurring when the moon was unusually close to our planet. Nandina is wondering, how long does it take to get to Pluto? Well, we know that because we sent a rocket to Pluto. So in 2006, we launched the New Horizons mission, and it arrived just under 10 years later. So the fastest rocket we have for getting out to the planets took about 10 years to get to the planet Pluto. Part of it really depends on whether you're going directly to a planet, how much lift you have, or whether you have to use the assist of going by other planets to get yourself to there. So it took longer for Voyager, for example, to get to Neptune, which is not as far away, as it did for New Horizons to get to the planet, or dwarf planet Pluto. Adam's wondering, how many rover cars were left on the moon? 3. Apollo 15, 16, and 17 all had moon buggies, and they're all there. And in the vacuum of space that the moon is, they'll be there forever, as will the footprints of the astronauts, unless someone comes along and rustles or disturbs them or takes them and puts them in a museum. Okay, looking for a couple of more questions. We have a question about whether it rains on Mars. We don't have rain on Mars because there's no liquid water. We do have amazing major dust storms on Mars, though. Mars has dust storms that will sometimes envelop the entire planet in dust. That happened 2 years ago when Mars was close in 2018. We were all ready for a big Martian celebration at Liberty Science Center, and it turns out there was a big dust storm that blocked off our views of the planets during that whole time. So Charlena is asking, I'll take this as the final question. It's a nice transition. Asking about other galaxies that have been discovered. So our next show, which is going to be next Thursday at 1 o'clock, will be all about galaxies. And that discovery of galaxies is a really important thing. We didn't know that there were other galaxies until the 1920s. We now know that the universe has at least as many galaxies as there are stars in our home galaxy. So our next program will in fact be the Galaxy Show at 1 o'clock next Thursday. Again, all of our programs here are stored on our LSC in the House website, and you can go and check out all of our past programming on astronomy and other topics there as well. Thank you again for joining us, and if you'd like to donate, we can always use the support, which is true for all planetariums and science centers and museums. So for now, thank you so much for joining us, and we hope to see you again next week when we explore the wonderful universe of galaxies. Thank you very much.